Hello everyone.
So today is gonna be our day 22 of the DSA challenge that we took. And the question today that we're gonna solve today is largest sub array with k sum. The question is on GFT and it is a kind of a different. It is a variation. As you can see that the sub array with k sum is given here, but in GFG, what you have given is largest sum is zero sum. So it's not k, it's zero here. You can update the algorithm that we'll discuss then with a and not zero, right? But here the question is a, so you don't sorry, the sum is has to be zero, so you don't have to worry about it. Let's try to understand how what the question is, right? So given an array having both positive and negative integers, so this is important, all right? So it contains negative integers as had this been only positive integers, the algorithm could have been a different one, like the optimal solution would have been different. But again, since here it is written positive and negative integers, the task is to compute the length of the largest subarray with some zero. All right, let's try to copy this code. Okay, I will copy this array and I will paste it over here. So we will one, right? And okay, so this is the array given. We know our k is zero. For this particular question, k is always going to be zero, right? All right. So what is a subarray first of all? All right. What is a subarray? So subarray is contiguous part of an array. All right. So what is a contiguous part? Now, as the word suggests, contiguous, basically the continuous part is called the subarray. So 15 minus 2 is a subarray. 15 comma minus 2 comma 2 is a subarray. But minus 2 minus 8 10 cannot make a subarray because they're not continuous in nature, right? They are not continuous in nature. Basically, what continuous means is that the indexes, right? The indexes should grow uh, in a pattern, right? They should be the just next. They should be just the next subarray. Though 7, 10, 23 can be a subarray, but a minus 8, 10, 23 cannot be because you are missing 1 and 7 in between, right? So I hope you understood what a subarray is. Yesterday we learned a question called subsequence, right? There you could have taken. So every subarray is a subsequence, but not every subsequence is a subarray. You need to know this, right? You need to know this. The contrary isn't the same. Okay. So let me just do one thing. Yeah. So what I'm gonna do is I will generate all the subarrays. I will generate all the subarrays. And if you remember, we did a question called if, where was it? Kadan's algorithm, right? This question. If you have seen already the video, you will know like how to generate all the subarrays. I'm not going to go in depth of it by how to generate it because I've already discussed in that video, right? So you can put your I counter here, j counter here, and j should be from I to 0. So if I write, so I will be starting from 0 and will go till n. And does where does your j start from? It should start from I, again go till n, right? And you can run a third loop as well. So let's just say if your j is somewhere here, right? Your j is somewhere here. To calculate the numbers in between, you can run a j loop, sorry, a k loop, which starts from I and goes till j, right? So this can be O of n cube, but again, we don't need this k loop. I've already discussed in that video that why don't you need the k loop for adding the sum, because you already know that what you're doing. You're doing 15, then you're saying 15 minus 2. I mean, then you are saying 15 minus 2 plus 2. So you're always, adding one element to the previous sum, to the prefix sum. So you don't need this. So this can be boiled down to O of n square. And then you can probably check that if sum is equal to k or whatever. If you are saying 0, then return. I mean, you can update the maximum length and then you can work upon it. But we will not use this. We will obviously go on to a better solution, right? Better, or you can say the optimal one. See, like I told you when I was reading the question, that this is important, that negative integers are also present. So if negative integers are also present, you need to know that this is the most optimal solution that we'll be discussing. But had it been given that only positive integers are given, the query, there could be one more optimal solution that you can do, which uses 2 point, which uses 2 point. I will discuss that in brief. I will, but okay. For now, let's do this. All right. Let's do one thing. Okay. Let's understand one thing. Let's just say you are given an array. Okay. You're given an array. You're given an array. You don't need to fill anything. Okay. You can just fill dots here. Okay. Cool. As just think of one thing. Okay. Let's just say I say from here till this point, till this dot, your sum is maybe s. So sum is equal to s. Okay. Cool. Okay. Let's just say when I was traversing, I got a sum. Okay, not till here. Let's just say I'll say that till here, I also got sum as s. Hear me out. Till here, I could find that the sum is equal to s. And till here also, basically, prefix. When I was traversing through this, I found that these two dots also make the sum s. What is the sum of these two elements then? I just think about it. Okay, just think about it. So let's just say four dots make sum s. Two dots from that four also make sum s. Remaining two, remaining two, remaining two dot. What is the sum of? It should be nothing but sum minus um what? Let's just say sum minus sum, because four dots, two dots also. Does that make zero? Does that make zero? Yes, it does. So the sum of it is zero. Just think of this one, okay? Just gulp this question, gulp this point in your brains. That's it, okay? Yeah, okay, cool. Let's have a map here, okay? Map. It stores uh maybe array of maybe sum, and till which point? Till the index. Let me erase this. Okay, cool. Now I will paste it here somewhere. Okay, great. Do I have a 15 in my so sum is 0 as of now. Max length is also 0 for now. For now, okay. And also just think that we will update maximum length only if we are getting the value greater than what it is present right now. So max length, whatever. Okay? We'll get it into the code, but just assume, okay. Is sum 15? So what it is? It is plus 15. It becomes 15 right now. Is 15 present? You will say no, it is not. So I will do 15 comma 0, right? 15 comma 0. Cool. Then next comes minus 2. What does it become? It becomes nothing but 13. Is 13 present? You will say no, it is not. So okay, 13 comma 1. Okay. Then comes 2 plus 2 becomes 11. Is 11 present? No. Does is one present? What is it? Plus one becomes 30. This is the point that you need to understand. Okay, where are we right now? We are at. I was here. Then it came to this minus two. Then plus two. Okay, sorry, not plus eight. It should be. It should be minus eight. I'm really sorry. I was here. Then I comes here. This is not 13. This is not 13. Sorry. What it is? It is nothing but. Uh, I think I've made a mistake. So 15 minus 15. Okay, okay. Let's try to do it again. Let's try to do it again. Let's try to do this again. No worries. We will. No problem. So 15 is the first element. Sum becomes 15. Add it. Okay. Then comes minus 2. It becomes 13. Okay. 13 added. Cool. Then comes 2 plus 2. Again becomes 15. Is 15 present? Just think of it. Is 15 present? You will say that yes, it is present, and the value at which it was present was 0. Till 0, it was 15. If till 15, till. Okay, now let me write this up. 15 minus 2. I will make a. Okay, till here, it was 15. Till here also, it is 15. What is the sum of this two? Correct? Correct? Yes. Okay. Let's try to update it. Let's try to update it. Our max length becomes, where are we right now? We are at 2. So 2 minus 0 is nothing but length becomes 2. Okay. Max length becomes 2 because 0, and we'll compare between 0 and 2. And I will not add 15. I will not add 15. Okay. Because I know that at 50, I know that at 15 comma 2, it should be added. But I will not add it. I will tell you the reason after. Okay. Cool. Now we are at here. That is minus 8. So it becomes 7. Was 7 present? No, it was. So 7, 3. Cool. Then comes 1. It becomes 8. Okay. No, it wasn't there. So 8 comma 4. Then comes 7 again. Okay. Am I doing any mistake? No, I'm not. 8. Then again, this 7 comes. Okay, this 7 comes. What is 8 plus 7? It becomes 15. Okay, okay. 15 was already at 0. Now I am at my I is nothing but 5. Should I write? I mean, I hope you understand. So if I say that this is minus 8, this is 1, this is 7. Okay, and let me erase all these things. Till here, it was 15. Till here, and sorry, and this is also 15. What is this? This is 0. Correct? Correct? Yes. So where was it present? It was present till 0. And what is this? This is 5, right? So what does the length become? It was this, and this. So it becomes nothing but 5. Max length becomes 5 now. So max length becomes 5. Great. Okay, no problem. No problem. Again, then comes 10. Okay. Was 15 plus 10, 25. Okay, not present, not present. So it will be IK 6. Yeah. And till then 23 also doesn't become. So we will update it in a minute. Now, one question is, why didn't I update 15? Why didn't I update 15? And why didn't I update it, like, when I was telling you that, hey, I will not update it. Okay. Had I updated it, okay, had I updated it, you will notice that if I update till here also it's 15, right? Till here also it's 15. So what does it become? So if this is 2, if I update it with 2, do you notice that only this becomes our sub array 8, 1 minus 8, 1, and 7 is becomes the sub array, and then the maximum length would just been 3. But including minus 2, 2, 8, 1, minus 8, 1, 7, this becomes a maximum. This becomes a longest one. That is why I did not update, because I knew that already if till here I need to minimize my left portion. So this is my left portion. This is my left portion, and this is my right portion. Correct? I need to minimize my left as much as possible. If I update it with a new value, if I update it with a new value, you will notice that it will decrease your right part. It will decrease your right part. So that is why I need to keep it as to its older value, to its oldest value, so that I get the maximum length, right? And this is how we will solve this question. Great, great. So I think we can now write the pseudo code. We can now write the pseudo code. Okay. So pseudo code. Let's just say I have a map which is nothing but new map initialized. Okay. I can have a max length which is equal, which is equal to 0, and a sum which is equal to 0. Correct? Okay. I will start my I loop from 0, will go till n, I plus plus, sum plus is equal to array of I. That is for sure. Correct. Now, if my sum is equal to 0, you can update it with k. Yeah, right. If the question is given to you largest sum array with k sum, but here since we already know what a k is, so we will not update it, right? So if this is, then what does your max length become? Max length becomes nothing but I plus 1. Why am I saying this? Why am I saying this? Just assume this. Okay. This is for the first time. This code is written only for the first time. Only for the first time till to calculate the prefix. To calculate the prefix. Till here we got 15. Till here we got 15 again. Had it been minus 2, then 2 as 0 and 1, I would add this. Then I would add this, and you would notice that this is the first sub array that we got, and the max length becomes 2. That is why this is happening. Okay, great. Else, let's just say if we are not getting it. Now what? Let's just say if I already have that sum somewhere in my map already. If map dot has sum, if it already has it, if it already has, then what? Then max length becomes nothing but max dot max of max length, and and what does it become? I minus map dot get what? Sum, right? If if the sum is already present at some point, so here if you notice, 15 was already present at 0. 15 was already present at 0, and I encountered 15 at 2. Then I encountered 15 at 5 also, right? At 5 also. So I need to subtract that. I need to subtract my 5 minus 0, this point, and this is how I'm doing it right here. Correct? Okay. Now, else, if it doesn't have, then nothing. then map dot set sum comma I, and you can return your maximum length. Correct? You can return your maximum. Let's try to code it. And what? Okay, yeah. What is a time complexity? Let's first discuss. O of n for sure. O of n for sure for running a full length loop. Okay. This map dot has all the map dot get, right? All these things are taking what? Log n. For people who don't know, it does take log n to find, since it might, use binary search or whatever. I don't know, but yeah, it takes log n. So this what it becomes n log n space complexity. An extra space. So since we are using an extra space, O of not exactly n, I could call it m, where n is greater than equal to m, right? I can say that. Is it better than n square or n cube? Yes, it is. Okay, great. Let's try to code it up now. Let map is equal to new map for sure. Let sum is equals to 0 and max length also becomes 0. Okay, let's start a for loop here. What was it? First, let's just add everything into our sum. Okay, if sum is equal to 0, then max length becomes I plus 1, correct? Else, if map dot has sum, then we know that hey, max length becomes map dot max of max length, and I minus map dot get sum, correct? Else, map dot set sum comma I and return max length. Right? Let's try to code. Let's try to run this. Expected output 5, your output 5. Let's try to submit it now. Great. Problem solved. Got the points. All the test cases passed. Great. Now I was talking to you about something. I was talking to you about something. Let's take this and let's assume, um, okay, I can do one thing. I can do one thing. Okay. Or maybe not. I don't want you to go into the depth of it, and I just take these as plus, right? And since you already know that all the positives cannot make sum 0, all the positives cannot make sum 0, let's take k to be something. Okay, k to be something. Let's just say it becomes nothing but 16, right? It becomes 16. Okay, no problem. Now let k is 16. I will start my 1 for I from here and j also from here. This is the one that contains the question that hey, all the sub arrays, find the longest sub array where k is equal to 60, where you have a k sum, and you need to notice that all the elements are positive, all the positive, right? This can now be solved in O of 2n, right? O of 2n. J is here. Let's try to increase j. Let's try to increase this j. Since we know that sum right now is 15, sum right now is 15, so plus 2. I will increase plus 2. Oh, it becomes 70. It becomes 70. Then I will do one thing. I will do one thing. I will decrease my pointer left from here till I will basically, shorten my sub array, because I know that Even if I from now, from this point, if my I is here, j is here, from this point, if I increase my j pointer, right, all the sum will either be 17 or more. This is for sure. If I attain a zero, or if I attain a positive number, it will always, the sum will always be greater. Then I need to know, because now that this sum has increased the k, I will decrease my left pointer because I need to shorten my subarray now, right? So j is here. Now comes j here. It becomes 4. Okay, no problem. Then j becomes at 8. It becomes 12. Again, less than k, no problem. Then this. What does this become? Um, what is it? I think I am, yeah, 13. 13. Then add this 7, right? This becomes what? This becomes what? This becomes 20. Now decrease it. I here, it becomes 18. What does 8 and 8, this becomes 10. Great. I will come here, right? This becomes 20 again. This becomes 20 again. Okay. So if this becomes 20, minus 1 becomes 19. Then again minus 7, it becomes 30. Not 30, it becomes 12. And in between, whenever you get 16, you have to update your maximum length. I know the it wouldn't be that intuitive to you, and this solution is not the exact solution that you are looking for. But again, you have to just do that thing only, that you have to use two pointers that will start from the same position. The sum will be initialized with the first element, and then you have to increase and decrease your right pointer and left pointer till the point that you get sum is equals to k, right? So yeah, let's do one thing. Let's write some notes here. Use a map data structure. And every time you get a sum, great. Accordingly, let's save it, mark it as done. Great. um I know it was not the see, the question was here given us some k, but we solved for 0. You will know that where we put that situation, right? Where sum is equal to 0, you can put a k over there as well if all the elements are can either be positive or negative. For positive, I've already told you, and you can probably watch this video as well. I think Striper has already put it on his YouTube channel. You can watch that as well. So yeah, thank you. So tomorrow's question will be, count the number of subarrays with given XOR k. Okay. I have. Let's see. We'll just solve this question tomorrow. And you, there is a question where you can, it's a variation of this question, that count the subarrays with k sum. Here it was largest subarray with k sum. Then you can also have count the subarrays, right? There can be multiple subarrays that make the sum k. So you can do that question as well. It will be available on either like Leetcode or GMT. You can see that. So yeah, tomorrow we'll meet with this question called count number of subarrays with given or k. Thank you so much for joining in. I'll see you tomorrow with another video. Bye.